We are doing winter 2023 paper 4-1 question number 2. Let's start. So like I discussed, this is a very simple paper with easy questions. Generally won't take much time. Where they're saying there's a linear queue that is implemented using 1D array called Q. The index of the first element is in the array is 0. Q is a global array with space up to 50 IDs of type string. So Q is 50 and it is string. Then head pointer, global pointer set to first element in the queue, which is pointing to -1. So head pointer will be -1, and the tail pointer they're saying that will be pointing to the next available space, which means it will always, first we will always save the value in queue, and then we'll increment the tail pointer by 1 because it is pointing to the next available space. And one thing to always remember in these questions is that whenever we are going to enqueue a value, since the head pointer is already set to -1, when we enqueue for the first time, we have to set the head pointer to 0 as well. This is a very common mistake in the paper. Students forget to do that, and then the head pointer remains the same even when there is one value added. Okay, so we have to just initialize these. I'll comment this out. This is just for note taking. Okay, so Q will be set to empty. Head pointer will be set to -1, and tail pointer will be set to 0. The procedure enqueue will take a string parameter. If the queue is full, the procedure outputs a suitable message. Okay, now when will the queue be full? This is again important mathematics. So let's say for the sake of example, we have 5 values in the queue. So 0, and we have 0 index, 1, 2, 3, 4. So there would be 5 values here, right? Okay, now when I have put in multiple values here, so I'm just writing dot 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 dot. So I have 1 value, then 2, then 3, 4, and 5 values. Now at this point, the tail pointer will be pointing to the next available space. So when the tail pointer is at pointing to 4, this is the next available space. So when I put a value here, let's say x, so tail pointer will now move to 5, right? So this is the indication in our case that if the tail pointer becomes greater than 4, then that means that the queue is full. So applying the same logic on our size of 50, so it would mean when the array becomes greater than the tail pointer becomes greater than 49. So this example makes it simple and easy to understand the math. There's very less confusion this way. So let's define enqueue, which will take a string parameter. Let's call it item. First we check if the queue is full, so we'll have to global all of these, global queue, and then we'll check if tail pointer is greater than 49 or is equal to 50, then we print that the queue is full. Okay, if that is not the case, else, so what we have to do is we have to add the value into the queue and we have to update the relevant pointers. Now, like I said, we always have to make sure that when we are adding the value, if the head pointer is already set to -1, then this time we have to set it to 0, which means that there is at least one value in queue now, right? Otherwise, the head pointer will keep on pointing to -1. So when I want to delete that one value that I have put in, that will not be deleted. So let's say I have a value y here, and since head pointer is pointing to a -1, it's not going to point at this index, which is wrong. Okay, once this is done, if the head pointer was set to -1, if that is done, then for any other value, what we have to do is we'll simply append the value in the queue. So queue dot append the item. And once this is done, like we discussed, we have to save the value first, and then we have to do tail pointer plus 1. So then I'll do tail pointer plus equal to 1. Let's hide this. Okay, then the next part is define dequeue. Okay, in dequeue, we have to globally access this.
+1.
Now in the questions you're saying the queue is empty, you have to output a suitable message. Otherwise, you have to dequeue the value. Now, the thing they said about head pointer is that it is set to -1. So when there is a value, it was pointing to that value basically. So if we have one value, head pointer is pointing to this index 0, which has y. When I pop the value, that would mean I'll delete the value. Technically, we're not going to delete it. We'll just move the head pointer to 1. So it goes to the next value, maybe that is x. And now head pointer is pointing to the current value that we have to delete. Tail pointer is pointing to the next value that is available. So these two are working a bit differently. We have all of this ready. Now let's check when would the queue would be empty. The queue would be empty when head pointer is equal to -1. And is this a linear queue or a circular queue? We should have checked that. It's a linear queue. Okay. So if head pointer is equal to -1, that means that the queue is entirely empty. Now there could be a case where, let's say, we have these values here and we keep on dequeuing these values. So head pointer, let's add a new line here. So maybe head pointer, tail pointer is pointing to index 3. That means this is where the last value was stored. And if I keep deleting value, I delete y, I replace it with a dash, I delete x, I replace with a dash, head pointer moves to 2. Then I delete this value, I replace it with a dash, and then I move on to the next index. Now tail pointer is pointing to the next available space, and head pointer is also pointing to the same thing. This must be empty, right? Because again, as the question said, that the tail pointer is always going to point to the next available free space. Now, since head pointer and tail pointer are both pointing to the same index, which is empty, that also means that the queue is empty. In this case, this would be true when the entirely queue is empty. And this would be true when there were some values in the queue, but you started deleting them one by one, and eventually you reach this point where there's no more value. So there are supposed to be two conditions here. When head pointer is equal to -1, or the head pointer becomes equal to the tail pointer. So if either of these conditions are true, then that means that the queue is empty. So we'll print that the queue is empty. And then the question says you have to return the string empty. So return empty like this. Okay, now once this is done, then they're saying otherwise you have to update the relevant pointers. So wherever the head pointer was lasting, we'll just update that value and we'll return the value. So let's store the value first. Let's call it deleted value. So deleted value will be wherever the head pointer is pointing to. So if it was pointing to index 2, this is the value we want to delete. We store it first, then we move the head pointer to the next index. I'll say head pointer plus equal to 1. And then finally, I will return the value that I have deleted. If I return before I update the pointer, that will not work because anything written after return is unreachable, and it will tell you this as well. This is something you already know, just a quick recap. Okay, so the code is unreachable. So I'll undo it, and return will instantly terminate the function. Okay, then the next part B. They are saying now that there is a text file. Let's open the text file. Okay. So this is a text file that contains a list of unique IDs of games. Procedure read data will read the data from the text file and insert in each item in the queue. Okay. Now they're saying each game has a unique ID of string data type. Okay, so we are not supposed to convert these into integers. Very simple. We just have to do file handling here and read everything into the file. So define read data. No parameters in it, so try and except print file processing error. And in the try, we will try to open the file. File is equal to open. Name of the file is queue data.txt. For line in F, let's just print line.strip. And this is purely for testing purposes. Even though they have not asked you to print the values yet, I'll still do that to make sure that you've done everything correctly till this point. So main. Okay, now if I run it, yep, it is printing all the values from the file, which means everything is happening correctly. So now we don't need to print these. Let's call it item. Let's strip the values. So white spaces are removed, and then we have to enqueue the values of the item. And then they're saying you have to just add them into the queue, and then you have to close the file. So file dot close. Nothing else needed. You don't even have to check the return value if the value was added or not. Now in the next part, they're saying some game IDs appear in the text file more than once. The program needs to total the number of times each game ID appears in the text file. Okay, let's look for an ID that is repeating. Here we go. 4, 5, 6, 7 is repeating on line 4, line 13, 17, and 20. Okay, so they're saying that you have to create a record data structure that will have an ID and a total, which will tell how many times this ID appears in the text file. You have to use the record data structure, and in Python you have to make a class for this to create this record structure. So let's hide this. Let's make the class on the top. You can make it anywhere. So class record data. We have to write the structure for this. So there are two properties here. So we have defined init self, and then there's going to be an ID. Let's call it ID, and then it's going to be a total. Let's call it TL, whatever you want to call it. So self dot, we can make them private. Did they ask us to make them private? Okay, they've not asked to make them private, so we don't need to. Self dot ID is equal to ID, and then self dot total is equal to TL, like this. It's done. Then they're saying a global 1D array called record stores up to 50 items of this record data type, and then global array number of records stores the number of records currently in the array and is initialized to 0. You have to write code to declare these. Okay, so we have to do this. Global array record, and let's call this number of records, which is set to 0 here. And then they're saying number of the records stores the number, and record stores up to 50 items. Okay, so we can just make it an empty array like this. Okay, this is done. If you are writing in Python, you have to include attribute declaration. Okay, we forgot that. So this would be declared as an integer. This would be declared as a data type of record data type. And similarly, here we also have to add these. ID is integer string, and total is integer as stated in the question. Okay, moving on. Now we are given pseudocode, which I guess will be converting into Python. So we have to do that. Uses dequeue. The algorithm is written for total data, which will use dequeue to remove an ID, checks whether a record data with the returned ID exists in the record, increments the total for that ID, creates a new record. Write the code for this procedure total data. Okay, so we don't really have to do anything here. We just have to convert this into Python. So define total data, and we have to globally access the variables. Let's get all of them, global number of records and global records as well. All right, we have to access data access is equal to dequeue. So data accessed, you have to use the same variable names and the same case sensitivity. Data access is equal to dequeue. We set the flag to false. If the number of records is equal to 0, then they're saying add the records array indexed by number records dot id number records. Okay, dot id. Now we can not do dot id here, right? So in fact we can dot id. Let's see if we set it to public. Yes, we set it to public, so we can use actually dot id here. If we had set it to a private attribute like this and like this, then we would have needed to use setter methods. Then we would have had to define set id, and then we had to place something like this. But since this was not a constraint given in the question, we can do it directly. So whatever the record array has stored at this specific index, we will go to that ID. Again, what is ID? This is the object of record data, which will have ID and a total. So we'll go to this ID, and then we can just change this to data accessed. Then records index number records dot total is equal to 1. Then flag will set to true, and then number of records plus equal to 1, like this. Flag should be lowercase. I think they're using uppercase F. Okay, so this should be uppercase, like this. Okay, then they are saying else if that is not the case. Okay, so one thing I just saw that we had created records as an empty array. Okay, so we cannot use this notation there. This notation is only used when the array is already initialized with some value. So if I had written records 0 for I in range 50, then it would have 50 values, and then I could have gone to those indices. But since the indices do not exist, so I cannot access it this way. Instead, I will have to append it into the record. So records dot append, and will manually increment the number of records. And I'll just say record.append. So we have to create the record data type with the data accessed and the total set to 1. Or this is confusing, let's get this out. Let's create an object here. This is fine, you can add a variable of your own. So what is data access? This is the value that we dequeued from the queue, which would be some ID, which we have read from the file. So maybe 1, 2, 3, 4. We have 1, 2, 3, 4 here. And then we are setting the total to 1 here as stated in the question. Once we have this object here, we are supposed to append this into the records array. Again, the reason I have to do this is because my record is set to empty. If you want to do it the other way, you can just assign some initial value for I in range, whatever the size of the array is, maybe 20, 50, and then you can use the simple convention method that we use. Okay, we set the flag to true, and then number of records is set to +1. All right. In else, we do for x in range, x should be capital, for x in range 0 to number record -1. So we'll just do 0 to number records. Why are we not doing -1? Perfect. Because Python range automatically does -1 from the value. Okay. If that is the case, then we are checking if records at this specific index x, that its ID there, if it is equal to data accessed. Okay. Simply, we have to convert this into Python. So records current index x dot. Okay, now we have to use ID, so we can use the ID directly. Since we didn't make it private, is equal to data accessed. Okay, if that is the case, then we are going to go to records index x dot total, and I'm going to increment 1. So plus equal to 1, and I have to set the flag to here again. Okay, this is done, and then what else? Okay, if flag is equal to false. So we have done this all as well. Now we go out of the else condition, and here we check if flag is equal to false, or you can just write if not flag. Then we are going to write records current number record dot total. This line is redundant because we've already placed the data access in total set to 1 in this object, and we have added the object here. So this line was from the previous logic, so we can get rid of it. Now this is much better. Okay, going back here. So we are, if the flag is not true, then we are going to the record, number of records index total, we are setting it to 1, and then records index number records ID becomes equal to data access, like they've said, and then again number of records plus equal to 1, and then that's it, and then we end. In part D, the procedure output records output the ID and the total of each record in the records in this format. Write the output records. So we'll do that. Define output records. Very simple program. We have define output records, and we simply have to print the ID and then the total. So for I in range, given the number of records that we have so far, and we have global number records, which is pointing to the number of values we have in the records array. We just have to print the values in this format. So format string, first of all, you have to print ID, literally ID, and then some spaces, then we have to print the ID. Okay, in order to get the ID, we have to go to the specific index number. So from our array records index I, whatever the ID we have of this object will get that, and whatever the total we have for this object, we get that records index I dot total, like this, and for I in range. Okay, we have to use global records as well. Now it's complete. Okay, then they're saying the main program needs to call the read data. So we've already done that. Call the total data. So we'll call total data for each element in the queue. Okay, so we already have the values from the queue. So we need to loop through them and we have to get all the values one by one. And then we have to call output records. Output records. Okay, now this has to be done inside a loop. They're saying for each element in the queue. So until the queue goes empty, we have to keep on getting the values over and over again. Now, when we get the values from the queue, let's see where are the values. Read data, we have DQ, call total data for each element in the queue. So we have this total data. Okay, it will already have DQ'd. Okay, it will already be DQing the value one at a time. Okay, so we just have to put a condition for when the queue becomes empty. And when the queue becomes empty, we know the condition was that the tail pointer would become equal to -1 or head pointer would become equal to tail pointer. So I'll just copy this condition. Again, why are we not dequeuing it? Because they're saying you have to use total data. And in the total data, we are already dequeuing the values one at a time. So we are not going to dequeue here again. Instead, we just have to loop until one of these conditions becomes true. So while head pointer is not equal to -1 and head pointer is not equal to the tail pointer, or we can just get rid of this and we can just have this one condition here. So as long as that is the case, we will keep on calling total data. And then once it is done, they're saying you have to call the output records. So we'll just put it outside the loop. Okay. And then they're saying you have to test your program and take a screenshot. Okay, so when we run this, we are getting the error here because we did the same mistake. So in this case, when the number of records are equal to 0, we're supposed to append something into the array and then we can access the values, right? So here we are setting the flag to false. And if the flag still remains false at this point, which means that none of this code works, because none of this code had worked. So our array was never populated. And since it was never populated, there is no object in it that we can access. So we have to repeat the same thing here. I'll just copy paste the code and this is it. We'll append it and then we'll do number of records +1 and then we run it again. Now when we run the code again with the correction, so it works perfectly. Let's check manually once as well. So we have 4, 5, 6, 7. It repeats 4 times. It repeats 4 times. 8, 5, 1, 2. 8, 5, 1, 2 should be 6 times. So 1, 2, 3, 4, 5, 6. Yes, it repeats 6 times. So this is the complete question, I believe. Yes, we're done.